Scoggin.
Dr. Scoggin, he's a crazy guy. And he
What you say.
has this this alligator operation that he is, believe it or not, that's something that he's into, an alligator operation. And he is actually thinking about purchasing a John Deere Gator because he thinks they're pretty cool, and he thinks that by purchasing a John Deere Gator, it will actually decrease the number of people that he has to have working for him in order to get his job done. So he's doing some research. He figures out that the vehicle costs $14,000, $14,500, and he thinks that it's going to have a life of about 8 years before selling it. When he sells it, he thinks it's basically going to have lost most of its value. It's going to be worth about $750 at the end of all that. He thinks that maintenance is probably going to cost him roughly $770 every 6 months. And just to make it simple, he's going to evaluate those thinking that maybe he'll have to pay that at the end of each of those 6-month periods. So he also thinks it's going to be able to help him reduce his staff by one part-time person. That part-time person earns $8.75 an hour. And that employee works 420 hours a year or so. Something that, if you haven't been an employer yet, that you may not have had to run into this, it costs an employer more than just the wages that they pay their employees to have employees. Things like insurance and things like taxes are also costs of having employees whenever you have those. And so basically, he's evaluating that about 18% more than the cost of the wages themselves is actually the total cost of having the employee. So he has to kind of factor that in as well. Okay, and we're going to assume that all of that stuff, those are payments that are going to have to be made at the end of each month. So if we assume an annual interest rate of 4% compounded monthly, what we want to do is figure out whether he does one or the other, basically what is going to be the difference in the amount of present value for all of the cash flows for each of these options. Okay, so that's the first part of the problem, is coming up with what's the difference in the total amount of present value of all these cash flows. And then the second part of the problem here is answering the question, what should we do then? Right? Should we buy the Gator and lay off the employee, or should we keep the employee and not buy the Gator? All right? So where would you like to start with this problem? The employee. Okay? So you want to start the problem by looking at the cost of having the employee over that period of time. Right? So kind of what we're coming up with there is there's going to be a difference of one employee, right? So that we can just look at the cost of that one employee each month and figure out what's the present value over all of this time. Okay? So, let me do it this way. I'm going to draw a little timeline here. I might not draw the whole thing, but I'll draw a little cash flow diagram. Here we're at time 0. And we're looking at basically for labor costs relative to what it would be if he had the Gator, right? It's going to cost him a certain amount each month. So let's say this is month 1, this is month 2, so on and so forth, 3. And we're going to have these cash flows out that will always be the same amount, and maybe I'll call that A. Right? And that continues on for however long until when? Okay, these are months, by the way. Okay, we'll go out to 8 years, which would be 96 months, right? So we go all the way out here to 96 months, and we would have the cost of that in the 96th month. Okay, well, what should that value A be? Okay? That's going to be part of it, right? Part of it is the monthly wage that you have to pay him. How do we calculate that? Okay. Hours he works per year. Okay, so he works how many hours per year? 420 hours per year. Then what? Okay, we need to then maybe figure out how many hours a month that is. Someone says divide by 12, so yeah, I agree that that's one of the conversions we probably want to do, is we want to turn this into months, right? And there are 12 months in a year. Okay, what else? Okay, we got to multiply by his wage, right? It's $8.75 an hour. All right, so let me put that in there as well. $8.75 per hour. Okay. Is that it? Okay. Yeah, this is the cost of the wages themselves, but it actually cost Dr. Scoggin 18% more than that. How do I deal with that? I can multiply by 1.18. Why is that valid? Right. It's basically 118%, right? It's that 18% above the cost of the wages themselves. Okay? Good. So now we need to calculate this. All right. So we have 420 times 875 times 1.18 divided by 12. Okay? So it's going to be about $361.38. Okay? That's my amount that I could actually save if I was to purchase the Gator, right? But I can't save it if I don't purchase the Gator. So we're basically counting this as a cost for this one employee that we get to save over this period of time. Okay? All right, so there's that. Let me actually store this value into A, because we might want it later. Now what? Okay. Now we need to look at that cost of that employee for 96 months. What formula are we really looking at? We're looking for P given A, right? Present value given that we have these regular amounts, these even amounts, you know, uniform amounts each time that we have them. Do you remember that formula? Okay, I think it goes 1 plus the interest rate. What's our interest rate? Okay, the annual interest rate is 4%, which is 0.04. We divide that by 12. Why? Yeah, this is we have to assume monthly compounding according to the instructions up here as far as how this this is to be evaluated. All right. Then what? Okay, this needs to probably be taken to some power, correct? 96. Yeah, 96, right? Because we have 96 instances of that. Minus 1, and then this gets divided by what? Okay, 0.04 over 12 again, right? That's the I down there in the denominator, times what? 1 plus 0.04 over 12, again raised to the 96. Okay, so my present value of all of those cash flows for that basically one extra employee is going to be put in my value of A. That was my cost each time, multiplied by, all right, put in this fraction here, and up in the numerator I'll have 1 plus another fraction here, 0.04 over 12. Then this gets raised to the 96, and from that I subtract 1. Down here I've got 0.04 over 12 times 1 plus 0.04 over 12, and that also gets raised to the 96th power. Okay, and so having that one extra employee basically is going to cost about $29,646.96. Okay, so this is cost of extra employee. Well, that's good so far, but that's not really what it's asking for, right? What is it that we need to know? We need to know the present cost of the Gator, right? Because that's what we're comparing against. It's either the Gator or this extra employee, right? And we need to basically take the difference between those two to answer the first question. All right, so how do we figure out the cost of the Gator? Shall we do a cash flow diagram? Why, yes, we should. Okay, so we start at time 0. What happens at time 0? Okay, we have the purchase cost of buying the Gator. How much is that purchase cost? $14,500. Okay, then what? Okay, we put in here, this is month 1, 2, 3, 4, 5. Something interesting happens at 6. Okay, yeah, basically he's got this $770 that's going to cost him every 6 months to make sure that the Gator is maintained in good working order. Okay, so that's something we have to put there, and that actually continues every 6 months. We're going to have a cost like that. Okay, and I'll tell you what, let me put in kind of a break in the timeline here. Let me also do this. We can actually kind of think about how often are we going to have those 770, like in a general sense. Okay, yeah, you're going to have that twice a year for 8 years, and so that's going to be 16 times. Maybe I don't need to put a break in this, but I wanted to show that there's going to be a break, and these are going to happen each of those. I'll tell you what, we'll start back up kind of 6 periods before we get to the end. That way we get to show kind of the pattern of it. Okay, so at the very end, what happens at the very end of this project? Okay, yeah, you get to sell it for $750. All right. All right, so the argument could be, do you pay the maintenance on it in the last month? All right. What kind of a guy do you think Dr. Scoggin is? He's not going to give a poorly maintained, he's getting $750 for it there at the end, so he's going to make sure it's maintained properly. All right. So it's going to cost him $770 in that last one as well. I understand if you want to argue that, but that's you know, based on what it says here, that's probably the fairest interpretation of what it's asking for. Okay? All right, so this is out here at 96. This was 95, 94, 93, 92, 91. So I need another one right here, 90. And I would have had a $770 there as well. All right. Now, how do I figure out the present value of these cash flows? Okay, I have a few things to consider, right? First of all, the easy one, right? Someone says that $14,500 happens right now, and that's when we're trying to figure it out, is right now, right? So I'll just go ahead and put that in. It doesn't need to be modified in any way. You just put that in as $14,500. Okay? Then what? You do have the salvage value at the end, which would actually be subtracted off of the cost that you're trying to evaluate here, right? So I would put in $750, but I don't get the entire value of that $750. What do I need to do to get a reasonable number that would be what that's worth right now? Okay? Multiply by 1 plus, okay, monthly interest rate, and again, and you get that by 0.04 over 12, raised to what? Okay, raised to the 96th power, actually not 96th, negative 96th, right? Okay, then what? This is the trickiest part of the problem right here. Okay, here's the tricky part. We have this cash flow that's happening every 6 months, but our compounding is happening every month. Okay, that throws a curveball of a little bit. All right, so what should we do about it? We actually don't have an equation that directly addresses this particular case. So what can we do instead? We divide the $770 by 6. Okay. A suggestion is we could divide the $770 by 6 and pretend like we have those in each month. Would that be exactly the same? Okay. I actually like the idea from a standpoint of, you know, something that's reasonable to do, but it won't give you the exact same answer as doing it exactly how it's asked. Okay? What would give this answer exactly? Okay? You could manually evaluate it. How would I do that? You could take each cash flow, there's 16 of them. You could take each cash flow separately and on a monthly compounding basis, bring it to the present and figure out the value of each one of those. Okay? So I'll tell you what. Let's do that for one of them real quick. All right? So what would that look like for one of them? Okay? The value that the amount that you're going to bring to the present is going to be $770, right? So we put in $770. And how do you bring it to the present? Okay. Raised to what? Okay. For the very first one, we're looking right now at just the very first one right here. There's going to be 6 periods, right, through which it has compounded. So it would be raised to the 6. That was nicely timed. I'm always looking to bring more drama into my lectures. Yes? Okay, question, 6 or negative 6? Is this right, or do I need to fix it? Okay, that cash flow, is it worth less or more because it's out in the future somewhere and you're trying to bring it back to the present? Okay. You need less money right now to be able to cover that cash flow than the actual face value of the cash flow, right? So given that, do I have it correct? Answer is no. I need that to be a negative 6. Just like I had negative 96 on the last one. It's really the same type of calculation. All right. So now, what would the next one look like? Same thing, but this gets multiplied by 2. What would the next one look like? Same thing, but that gets multiplied by 3. And so on and so forth. So my question is there a way I could shorthand this with some interesting notation? Is there a way I could shorthand this with a summation notation? Okay. What if I use a summation notation where I use a variable of x, and I start with x equal 1, and I go up to what? X equals 16? And then what? This is going to be applied to all of this, and I take 6 and I multiply it by x. Okay? Does that make sense? And here's the great thing. That wouldn't help you a whole lot if you didn't have a slick calculator to put that in. But you do. And so we're going to go ahead and stick that in, and we're knocking on the door of being done with this problem. So we'll put in 14,500 minus 750 times 1 plus 0.04 over 12. That gets raised to the negative 96. Okay. And to this I'm going to add, if you don't recall this, the keystroke to get there, at least on the Casio, you hit Shift, and then right above this right above the log key right there, you'll see that there's a little summation notation construct. So I'm going to get that in there, and I will enter the formula that is inside of this summation construction. So we have 770 times, okay, inside of there I put 1 plus 0.04 over 12. And then this gets raised to what? Negative 6 times x. Okay, and when you're finished there, hit the forward arrow until it lets you put the correct things in the limits of this sum. So we put in x equal to 1, and that goes up to 16. Okay, and I think that's about everything that we need to put in the calculator. So we hit equals, and it tells us that our overall cost of having the Gator and one less employee, right, is going to be $24,396.08. $396.08. All right. So now we have this value of $29,646.96 and $24,396.08. What we need to do is subtract. So 29,646.96 minus 24,396.08, which gives us a difference of 5,250.88. So the difference, 5,250.88. All right. So what should we answer? The answer is I, $5,250.88. And then the answer to the second part of the question is, should he buy the Gator or should he not? Okay. It looks like buying the Gator represents a lower amount of present cost to him than the cost of having the employee, right? So he chooses to buy the Gator and lay off the employee. Of course, you might argue, Dr. Scoggin is a decent fellow, and he cares about people's well-being, and he would rather have that employee rather than buy that Gator. Or do you know him as well as you think you know him? Yeah, the scare music, yes. Yeah, what's the question? Yep. So the question is, why do I have to figure out the present value of the salvage cost or the salvage value of $750 that you get at the end of the project? The reason for that is if you want to count that as being presently worth something, then you have to take away the fact that you don't get it for 8 years relative to right now, right? So in other words, if that was money that was tied up for that entire 8 years, it would be worth more than the face value, right? Or if it's where you need that amount of money, or you're planning on getting that amount of money, but it won't be for a long time, it's actually worth less because it's further away from now. Yeah, you're just trying to make sure you're fairly evaluating each of the benefits or costs that come with a project, right? And so anytime there's a projected benefit, but you don't get it for a large number of years, well then it's not fair to count the actual face value of that benefit you get a number of years from now. If you're doing a present value analysis, you can't count it at face value because you don't get it right now, right? You have to say, I get it, but it's going to be many, many years from now, and so the actual value is less than if I could have had it right now. That's kind of the idea of the time value of money. All right. Any other questions? Yes, sir.
Where did you get the 1.88 from?
So the 1.18, question is, where did this value of 1.18 come from right here? And the answer is, it says right here that he's going to have to pay insurance and taxes such that it's 18% above and beyond what he actually has to pay in wages, right? So whatever he pays in wages, 18% of that he's actually paying either to insurance companies or to the government because he hires somebody, right? And that's a real thing, right? That's some people don't recognize that, but when a company hires an employee, there are many costs like that to having the employee that do not translate into that money going straight to the employee themselves. Yes, sir.
Could you calculate that separately? Like, could you calculate the wage value and then the 18% of the wage value and just add them together?
Yes. Yeah, it would be the same.
It's just a little more work.
Yeah, you'd have two terms in there instead of one. Yes.
Rather than the summation wage did, what if you said the interest rate was semi-annual rather than monthly?
So that wouldn't actually be the same thing. Like if we set overall and say we want to count our time value of money calculations based on monthly compounding, it's not the same thing to say that it's going to be semi-annual compounding. So that could be done, it just doesn't match what the question's asking for. All right. Anything else? Fabulous. We have helped Dr. Scoggin out immensely. He can get rid of his dead weight and he can buy his John Deere Gator, and he's going to be so happy. Yes, ma'am.
About how hard would you rank this in terms of tests? Where could we, about what number?
This is what I would call a very average alligator problem in terms of difficulty.
Okay.